All right, 4.6 C, elementary algebra. We are on the last example here having to do with exponential decay. So we got a radio element, carbon-14, or the radioactive element carbon-14 has a half-life of 5,750 years. The percentage of carbon-14 present in the remains of organic matter can be used to determine the age of that organic matter. So they're saying they can figure out how old something is by measuring how much carbon-14 is still in that organism, because everything has carbon-14 in it. The problem is certain things that they have done carbon-14 dating, they've proved that it's inaccurate. For example, they checked a volcano in Hawaii, and as it erupted and lava spewed and formed rocks, they did carbon-14 dating on the rocks that were newly formed, and it said the rocks were millions of years old. Well, the rocks were newly formed. They just came out of the volcano. So the carbon-14 is just kind of a crock as far as I'm concerned, but as far as a Christian is concerned, because they say really stupid things. But anyway, enough of my whining about carbon-14 dating. Archaeologists discovered that the linen wrapping from one of the Dead Sea Scrolls, and if you look on the left column, it tells you a little bit about the Dead Sea Scrolls. So they found Dead Sea Scrolls had lost 22.3% of its carbon-14 at the time it was found. How old was the linen wrapping? All right, so we take our formula, P T equals P O E negative K T. So we take our formula. All right, we write, and what we're going to do, first of all, is we have to find out what K is first. Okay? So, when T is 5,750, which is the half-life of carbon, P of T will be half of P of O. Okay? So, that carbon that was in here, the half-life is 5,750. So, what we have left right here will be half of what we started with in 5,750 years. This amount of carbon in 5,750 years will be half of what we started with. That's what half-life is. How many years did it go from its original state or original amount of carbon to half of it? All right? So, what I'm going to do is I'm going to replace P of T with 1/2 my original. Okay? Makes sense? And that will equal P O E negative K T. All right. Now, notice what I have here. When those things are multiplied, you can just get rid of them if they're the exact same. So, that's old junior high math. So we have that. Now we take the ln of both sides, because we have a t up here and a k, or I guess more of the k of what we're looking for. That's our exponent, and it's our unknown. So we have ln of 1/2 equals negative kt. Okay? But what is our t? Our t is the 5,000, what was it? 5,750. So let's keep going here. Let's divide by negative 5,750, because we're dividing by that. So that goes away, that goes away. So we have k equals ln of 0.5 divided by negative 5,750, giving us a k value of 0.00012. Okay? So we found K. Okay, so what we're trying to do here is find out how old this linen wrapping was. All right, but we had to find K to do that, and you're always finding K first. So I'm going to take some of this stuff and get it out of the way. I want to leave my K right there, and I want that formula up there. All right, so what does it say about the carbon-14? It said that it had lost 22.3%. Well, it lost that much, then it still has 77.7% left over, right? So we still have 77.7% of the original left over. Okay? And what are we trying to find? We're trying to find T, how old it was. So we're going to put our original equation back here. And we have negative point, and K we found was right here. And we have T. We're looking for T. We're looking for the amount of time. Okay, remember what I said? When we have this here and this here, we can get rid of those. Change this to a decimal. Because we're looking for this, we're going to take the logarithm, both sides. So ln of 0.777 equals, this whole thing goes in the front. This equals 1, so it can go away. Divide by 0.00012, negative. That whole thing goes away. And we get our T. And they're saying that the Dead Sea Scrolls are 2,103 years ago. They were hidden, or they were made, or whatever. Okay, so that is exponential decay. So whenever you're doing these, remember you have to find K first. Once you find K, then you start looking at the problem and doing some other stuff in there. Okay, so that is it for 4.6.